So this is again theoretical things regarding network. But all these things that you are studying theoretically, you will have a chance to do practically also later. So again we have some concepts. Let's see what it is here.
USB? Ayun. Rice? Yung mismo, email. Oo. Rice. Extra. Saan yung ginamit ka naman? Second year.
Nakalimutan ko na.
Rice. Pero alam mo ba?
Oh, alam ko yung password na.
Yung public key. Buksan mo na nakita.
Okay, the basics, so we'll see some of the basic things here. So a network is basically a group of interconnected devices, right? It doesn't have to be a computer, it can be any different thing. Yeah, printers, phones, PCs, laptops. Okay, so you can categorize networks based on different angles. Based on the geographical criteria, so you can classify networks based on LANs, CAN, MAN, WAN. Basically, we just have LAN and WAN, okay? But these are just exaggerated. So LAN is, the network of a single company, a single building within a building. With respect to geographically speaking, or how much space it can go. Now again, logically also you can have two different LANs in the same building. Okay, logically, but physically speaking, a LAN is you can say anything under 1 square kilometer. You can say as LAN. CAN, that is campus area network, which is a big campus. Okay, which spreads a lot of area. Then you can say CAN, but again that come under the LAN principle. MAN, metropolitan, that's a network of a city, a little bit bigger. WAN, that's the internet. I mean, the internet is not the only LAN. You have many other WANs that we don't know, right? Because they are private. The internet we know because it's public. So WAN is something that connects many different countries, many different continents, isn't it? So this is a typical arrangement in a LAN, isn't it? So you have clients. All the clients are connected to a central device called switch. The switch connects to the router. Now, if you say logically, then there are two LANs here, right? Now this part is one LAN, and this part is another LAN. You can say LAN, it's another network. Okay, so because a router breaks a network. Right? So you have one network here with the file servers and clients connected to switch. You have a router, and you have another network here. So we know that we use 802.3 standard for Ethernet, which is for cables. Ethernet cables, and 802.11 for Wi-Fi, wireless, RJ45 connectors everywhere, isn't it? The default things. There are many terms out there that are actually you haven't studied. Like you don't know what is MPLS, ATM. Okay, these are all WAN technologies. Now, in case of LAN, there is only one or two, whether it is Ethernet or Wi-Fi. 802.3 or 802.11. Right, 99% of LANs in the world all use these technology. But in case of WAN, there are many different networks. Nobody knows what's in the WAN because it's rarely used. Only ISPs use it. Right? It can be MPLS technology or it can be ATM. I'm not talking about the media. Media can be fiber, satellite. I'm talking about the methodology, the way the data is carried. Okay, the protocols. There are many different. In LAN, it's Ethernet. Okay, you just say Ethernet. Topologies. Now these are actually outdated. We don't bother these topologies, but we had these topologies before. Okay, topology is basically how you arrange things in LAN. Okay, I'm talking about LAN. So you can arrange like this. Okay. So there is no central device. You don't have a central switch. It's this. You have a big cable and everything is connected to that cable. And you will have endpoints here. That's the terminators here. Okay, that's bus topology. We no more use it. And you have star topology. Now this is the one that we use now. Okay, we use actually a high bus, but this is the base topology we use. We have a central switch hub or router and we connect everything to it. And that one will connect to the upper one, the uplink. Okay. Like if you think about our Aptech here, we have 15, 16 PCs in one lab. All this will connect to one switch. So every lab will connect to one switch. Right? And all the switches will join together and connect to a main switch. And that will go to the router, right? So hierarchy. Ring topology. We don't use this one also. Here also there is no switch or it's just a ring. Okay. Now we will see these things. Okay, just remember it. Right now just remember it. We will see these things practically. Mesh. What's the difference between a ring and a mesh? You have full connectivity, redundancy. So if this in a ring, if this PC wants to talk to this PC, it has to go like this, clockwise, right? It has to go to computer 2, 3, 4, like this. But in a mesh, a full mesh or partial mesh, you have full connectivity, one-to-one connectivity. Again, this is also we don't use. Okay, we use star topology. Okay, this is a partial mesh. Now we use these topologies in WAN. Okay, not in WAN. Not in LAN. The topology that we use is what do we say? Ring. Sorry, star topology. Okay, this is the topology that we use. And we actually use a hybrid. We combine with bus and all. And there are different types of models: client server, peer-to-peer, centralized, hierarchical. Client server means you know what client server is, right? These are all very loose terms, okay? It's not like we completely use client server. So you have client and you have a file server, all your files are here. Okay, and whenever you want a file, you access the file server. So all these clients will be accessing the file server. Okay, so this is the server and clients, that's a model. Similarly, in case of printer, there is only one printer. All the clients, including this file server, will contact the printer for printing. So this is client server model. Okay. So it depends upon what service you are accessing. Peer-to-peer model, there is no server. Everyone has equal amount of data, equal importance. Okay. There is no particular server. Even you see the printer, it's not directly connected. It's connected to a printer, sorry, PC. Okay, everybody is same. Peer-to-peer. Centralized model, that's more control is given to the server. Okay, server will have everything. Okay, including the data storage, memory, processing, everything will be on the server. But in client server, client will have the processing, storage, little bit storage, like ours. We are using client server model. Right? Your PCs are not dumb, just dumb PCs. But here these PCs are dumb PCs, dumb terminals. They just have the display. Okay, and the software installation, everything will be on the central computer. Okay, everything goes and comes. Okay, if you want to start a program, the program is here. You have to start it from here. It has to load through the network. Okay, that's centralized. That is also famous. You know, we spoke about virtualization, right? In virtualization, we use this thing. Hierarchy. Yeah, this is the one that we use. Actually, we don't use client server. We use client server up till here, but after that, it's hierarchy. Okay, this is a 3-level model. Now it applies for big network. Okay, like I told you, right? You have this maybe one lab. Okay, all the pieces are connected to the switch. This may be another lab. Like this, you have many labs, and they will be connected to a router, okay, and they may be connected to another router or another switch, and then these will be connected to the internet. And you can see there is links everywhere, redundant links. So even if one link fails, the other link, if this link fails, what will happen? Then this whole thing is cut off, right? Yeah, there is no redundancy. You should have some link like this. You should have a link like this, isn't it? Otherwise, if this one fails, or if this one fails, it can go like this. So that's the basics of network. Basic idea. So basically you have core layer, distribution layer. This is core layer. And this is core layer, distribution layer and access layer. 3 layers.
Come again, sir?
Access layer, distribution layer, core layer. Core. These are actually the recommended network models. You can't just make a network like your own. Like let's say for example you are starting a company, okay? So you initially have 10 computers. So you put a switch, 10 computers, and you have a router. You keep on growing, 10 becomes 20, 20 becomes 50, 100. Okay, so what do? You put another switch, you connect them, some computers there, you connect this switch with the other switch, and you keep on chaining like that. That's not recommended. Then you'll have a lot of problems in the network. If you're growing, you should grow like this. Okay, you should go, it means you put 3 switches here, okay, you connect here, you put another 3, you connect here. 4th one, you should have another router here. Okay. You should grow hierarchically. You cannot just daisy chain. Alright, so those are the different models, standards and topologies. Okay, physically speaking, how you arrange things. Okay, now we have another model. Now this is a software model. So network is not just hardware, right? Now if you speak about the arrangement, okay, this switch is a hardware. You might find router is a hardware, but there are softwares running inside it. Like switch manages the MAC address, router manages the IP addresses. Okay, so there are softwares also running in it. Okay, so that's the second part. What are the software models? So here, the famous model is OSI. It's very old, 1977. Even before the internet came, because right after the computers, right, we had a network. So networks came in 1970s, at least at the LAN level. At that time, we need a switch, hub, and all these things that came in 1970s. So the model also came. Actually, the model came and then the equipments came. So here, model means it's like a blueprint. Okay, blueprint of what a network equipment should have and what a network equipment should not have. It's a standard. Like if you manufacture a phone, for example. Okay, now there are no standards in a phone. different companies have. Let's say a Samsung phone. A Samsung phone should have they have a blueprint. Okay, they have a place where to keep the camera. They have a place where to keep the battery and what type of battery, how many volts. Okay, what's the arrangement? When they print the motherboard, they have the circuit standards. Okay, they make some adjustment in the standards. They make some compromise in the standards. The phone simply won't work. So everything is based on that. Say let's not put this capacitor and let's put something else. It's not going to work. It's going to blow up. Right? So any device manufacturer should follow these standards, these OSI standards. If it's not following it, then it's not as per the industry. It may not be compatible with the other devices. So you have a HP switch and a Dell router. It won't work together if they follow different standards. Simply you think about the hardware, okay, you are plugging a serial cable, 15-pin serial cable. So the cable is 15 pins, but you have only 14 holes. How can you plug in a cable in that? So everything, hardware, software, everything should have standards. So these standards again are maintained by IEEE. So if you are planning to manufacture a cable or any networking equipment, you should get the license from IEEE. You can manufacture only as per their standards. And these OSI model, it has 7 layers. And each and every layer can be mapped to a particular function in the network. Whatever happens in a network, whether you are downloading, uploading, basically you do download, upload, right? That's what data transfer happens in network. So when you do data transfer, no matter what kind of data, if you think about you saw that video, right? How the data transfers from one point to another point. So at whichever point you are, you can actually pinpoint that the data is right now, it's here. Okay. So you can see physical, data link, network, transport, session, presentation, application. See, host A, host B. Okay, that means two clients are there. Let's say 2 computers are communicating, 2 computers are transferring data. Now what are the layers or what are the phases the data has to pass through? Okay, so you can see here, you can either take it from the bottom or take it from the top. It's all up to you. So if you're sending data like this, see it goes from top to bottom and then goes to the host B and bottom to top. Right? So application means the software. Right? So when you're using browser and if you're downloading, if you're clicking on an image, so the data, the process originates in the software browser. So that's application is first. And when you click presentation, presentation is not GUI. Okay, presentation means how you present the data, how you pack the data, how you format the data. Okay, you put in a packet and you seal it. Okay, these kind of things. Session, like when you contact, when you contact another computer, whether it be a server. Now I'm contacting Google, right? Now Google is the second person. So I have to establish a session between me and Google. I have to establish a link. If I don't establish a link, then the packet will be lost in the ocean. It's basically like you have to establish the circuit. Okay, speaking. Right? Whenever you search in Google, there is some considerable amount of electricity spent. See, when I press this, enter some watts of electricity spent. It's you can say that. Yeah. If you have a LED light, imagine how much electricity you need for the LED light to work for 2 hours. That much electricity you are doing when pressing an enter. Because when you enter, what happens? You see it's electrical signals, right? It has to go all the way back to USA. How much electricity you need for that? Imagine. If you're sending an email, the electricity is going all the way back to somewhere else in the world. And all the devices in the middle, they are boosting electricity. It has a cost, has a price. Right? So that's, you're building a circuit here, session. Okay, all the handshaking, everything goes here. And then you have transport layer that takes care of the transportation. You have a network layer that takes care of the logical part, IP addressing and things like that. And you have a data link layer that takes care of the physical part, physical addressing, like MAC address. And of course you have a physical layer that will take care of the bits or the binaries. That means when the data comes to this point, everything will be binary, zeros and ones. And these zeros and ones go into the destination computer. It will unpack, data link layer will again unpack, and finally it comes to the software, whichever software is processing it. And normally if it is a web browser, then there will be an equivalent web server, like IIS or Apache server, that process the request and gives you the response. So that's the software.
So, what is Apache again?
Apache is a web server. You're using websites, right? You're launching websites.
Okay.
If you want to launch a website, what do you need? You need a server where you want to launch. Plus, you need a software to control the website. The software to control the website is web server.
That's Apache.
Like SQL server, you studied SQL server,
Yes,
right?
yes.
SQL server is a software to control the database.
Database.
Just like that, Apache is a software to control the website. In Windows, it's IIS.
IIS. IIS.
You can see here, the first three layers, it's all data, and transport layer, it segments, network layer, it becomes packets, data link layer, it becomes frames, and then finally physical layer, it becomes bits. Okay. Actually, you can do reading here, but actually we will study this once again in CCNA. But if we study it now itself, we can just revise it. Let me see whether I have. Actually, a lot of things happens in these layers.